All right, folks, I'm back. I've got a new cup of coffee here, given to me by a very good friend of mine who dropped it off this week, and I must say it's very very good. Yeah, it tastes really good. So my thanks go out to him. Okay, this is ridiculous because I was thinking about this as I was doing my chores and yard work in the interim. This doesn't make sense that it would be calculating a different value. I mean, a pixel is either black or it's not. Why are we getting a different value from what we had before? So what I'm going to do is we're going to go back to where we captured this data, the digit recognition test project. And black percent is a decimal. We captured these as decimal values. And everything about this is decimal. Then we came over here into the Tetris data extractor, into the digit reader, and we made a dictionary of doubles. And I think the problem is this representation is not a decimal value. In order for it to be a decimal value, you have to put an M beside it. See, now I get squiggly lines saying this isn't a decimal value. So if I make the dictionary, if I turn it back into a decimal dictionary, let's just take a look here, because I always confuse myself. Decimal versus double. Is there something? Yes, the C# reference guide. So a decimal, the precision is 28 to 29 digits. The precision of a double is 15 to 17 digits. But what you get from using a double is you can go up to values 10 to the 308. You know, that's almost like 4 times the number of particles in the known universe. So you get a wider range, but you don't get as many decimal places. You don't get that precision. A float is 6 to 9 digits, and it's from minus 45 to 38, and that's what I was doing wrong. I had put F beside some of my numbers, and I turned them into floating point digits, changing them at the, the 9th digit after the decimal point, which was totally ruining my thing. So what I'm going to do is we're going to keep everything decimal. Everything will be decimal, and I will append any constant values with an M, just so that we keep all our precision. Now, we don't need this many, but if we don't use the same type everywhere, see here I was turning it into a floating point number, which has a lot less precision than a decimal value. And here we're going to, basically I'm just going to replace all the doubles with decimal. Go. In the current document, replace all. There we go. 11 occurrences changed. So now we've got decimals everywhere, and I don't have any compile errors. So let's get rid of this line. Let us run our test again, and hopefully, let's just debug this test. This is the number 0 test. Okay, so this is file name 0, expected digit is 0. Let's do it. Let's create the image and we'll run our test. So the fingerprint is 64672. This looks good. So we'll go into the is 0, and I'm sure it will return true. There we go. So we return 0. We go back to our test, and now digit is the character representation of 0, and that should be the same as the expected digit, which it is. This carries on its merry way, and we get that check mark. So in the same way I expect 1 to work, this is 2. I'm building up for it. 3 works, 4 works, 5 works. There's our green check mark. Now remember, this is 6. This is different. I'd like to debug 6. Sometimes I like to debug tests even before I run them once because it's a little bit nerve-wracking and I want to see every step of the way. So indeed, we're expecting this to be recognized as 6. So let's go into here. Oh, this is 0. We don't want that. So it's not 0, it's not 1 or 2 or 3 or 4 or 5. Now 6, we're passing in the bitmap, and we're just going to make sure that the fingerprint is the same, but still at this point we need to differentiate between the 6 and the 9. So we're gonna get the top percentage and the bottom percentage. So hopefully I'm right. Hopefully there is more black in the top than the bottom. So there's 63.9 in the top, and the bottom has 0. So something's wrong with my bottom. But because top is less than bottom, oh, top is not less than bottom. So this is going to actually spit out. It's not going to be a 6. It's not going to be an 8. However, it's going to try for the 9. And because I have a bug in my program, bottom is not being calculated properly. It's 0. So top now, oh, did I not? Oh, interesting. That'll be another bug. So we couldn't figure it out, and so we're going to throw this exception. And we're going to get this very jarring red X here. So if I can actually run every single one of my tests, and I'm going to get 2 errors. Fancy that, at the 6 and the 9. So something is wrong with my 9, or the way I get my bottom. So let's see why that happens. So let's go to the 6. We'll put a breakpoint here, and we'll debug this. We seem to be able to get the top of the image, but not the bottom. So the top seems to be fine. Let's go into the bottom. So the image itself, the width is 45. That makes sense. The height is 19. That's what you get when you take 39, the actual height of the image, divide it by 2, and then throw away all the decimals, because integer values can't have decimals. So that makes sense. The X offset should be 0, because that's the top left, that's the leftmost pixel. The Y offset should be 19 as well. Interesting. Okay. So the total pixel is the width times the height, which it's telling me is 855, and I have 0 black pixels. So let's begin. X starts off at 0, and I can actually pin this here. How nice is that? So there's my X value. And I'm going to attach my Y value here. So there we go. And then we'll just keep going. Oh. Perfect. So because y starts off at 19 and the height is 19, I only do this loop when my y value is less than height, and because it's never less than height, it doesn't do the inner loop. So that's a bug. So what do I have to do instead is I want to go from y offset to height plus y offset. And this way, if my y offset is 0, I will go from 0 to 19. And if my y offset is 19, I'll go from 19 to 38, which is exactly what I want. And I'm going to be missing the bottom row of pixel, but because it's a 39 height, I think I've got some resolution issues as the actual Nintendo screen, the 256 by 200, I think it was, expands to 1411 1080. I think I lose a pixel in there somewhere. And but that should be fine. This is just, is it bigger than or less than the top of the bottom half? Okay, that should work. So now let me debug this. I want to actually see this go. Let's put a breakpoint right there. Okay. Oh, and I've got all these breakpoints here. Lovely. I don't want to stop there anymore. Okay, so here we go. See, now y is 0. Or y, it's red because it hasn't been set yet. It starts off at 0. Oh, because we're doing the top half. Whoops. Now we're doing the bottom half. Okay, here we go. X starts off at 0. Y starts off at 19. And we want to make sure that it's less than 38, the 19 plus the 19. So if it's black, then we add 1 to black pixels. This is perfect. I'm going to click here to run the rest of this method and step out. Okay, so now we've got the top, which is 63.97, and the bottom, which is 50. Is the top less than the bottom? No. Top is not less than bottom. So this is gonna conk out, and I just realized that I got my, yeah, it's gonna say I can't figure out what's going on. So there's a couple of issues here. Is 6. I'm saying the top has more black pixels than the bottom, so this needs to be greater than. Is 9. This is right. Top is less than the bottom. Okay, now I'm just going to run 6 and see. We won't be debugging it. I want to see the green check mark. Ha! Okay, now does 9 work? No, it does not. So it saw that it was 6. Okay, well that's fine. I'm going to take all of my breakpoints. Just kill them all. I'm not sure how many I had. Okay, let's let's go into here. Obviously, so it's not picking up 9. It thinks it's 6. So if I just have a breakpoint here, it is 9, and then I debug this, I'm expecting this to hit, but it's not. It's saying, look, what I actually think it is it's 6. That's not right. So for some reason, my 9 is being thought of as 6. So let's debug here. And we'll go into this. Okay, so we've got our fingerprint. It is the 6 and 9 value. It's not 0, 1, 2, 3, 4, 5. Now this is saying, for some reason, that it's 6, and I'm not sure why. So the top is 57.89% black. The bottom, oh my word. There's more black on the top than the bottom. What? But so that's why, because top is greater than bottom here, but just barely. Like just barely. Have I got this wrong? Where's my 9? Bring this down. Do these two look the same? Bitmap width, bitmap height divided by 2, 0, 0. Bitmap width, bitmap height divided by 2, 0. Bitmap height divided by 2. So I can't seem to recognize a 9. And the thing is, my 6 and I think the problem is, you see that the 9 only has one row of pixels on the bottom that are black, but the 6 has 3. So when we chop this in half, this is like right here or something. Or no, it's up a little bit. But we're including all of these pixels in the 6. But the 9 is a little bit offset. Yes. And so there really is more black pixels, or almost more black pixels in the top of the 9, because it's got all this headroom of 8. So it's the imperfectness of my box, which is too bad. The other, like we can, the other thing we could do is, instead of chopping it in vertically in 2, we could, or horizontally, we could chop it vertically, because the 9 definitely has less black pixels on the right. The 6 has less pixels on the left. That might give us a better understanding of the difference between a 6 and a 9. So let's try that. Like for now, we've got everything passing except for the 9. So let's take the 6, and instead of getting the percent, instead of cutting it in half horizontally, let's instead cut it in half vertically. So the top, we'll rename this to left, and the left still the same. This time it's width divided by 2, and the height is the same. This will be width divided by 2. The height is the same as the original. The X offset will be bitmap width divided by 2, and the Y offset will be 0. And this becomes right. Okay, so that's the width of my image, half the width, the full height. The X offset is going to be right in the middle, and the Y offset will be 0. So that is what I want. So let's try that. Let's bring that over to the 9. Because we want to do the same thing. So now I have left and right. So if it's a 9, I think the left I'm saying the left has more black pixels so the left is greater than the right. And if it's a 6, I'm going to say the left has less black pixels than the right. Okay, let's check that out. Okay. Let's see what happens. Let me run all of my tests. Oh, and now the 6 doesn't work. What? Okay, all right, let's maybe it's not as simple. I have to come up with more complicated and more intricate and more solid ways of determining what a 6 is. So the left has 53.4% black, and the right, oh, I did my thing again. Haha. Because now I'm doing plus X offset. See, I forgot to do that check there. Okay, so let's debug this one more time. This is the 6. This time, so the left is 53.49 and the right is 60. Left is less than right, so it's a 6. How about the 9? Let's put a breakpoint in the 9. Oh, it is already. So the reason cutting it in half horizontally didn't work is because both images were slightly offset from one another in the horizontal and the vertical direction. This should hopefully work because they seem to be, okay, 64.4 on the left, just totally dead 50 on the right. Left is bigger than right, and so it's a 9, and I'm going to get a green check mark. And so now I can run all of my stuff. I get green check marks everywhere. And now this is where I fix things up. Because this looks horrible. It's too many. It's too many lines. I think what I want to do, I think NUnit has a test case source, and I can. Can I just say enumerable.range 0 and then 10? Can I do that? No, of course I can't do that. Okay, we'll leave it. We'll leave it as all these test cases. It'll be all right. Okay, so that's it. This runs. Kill all of that. Yes. Test Explorer. Run all my tests one more time just to see how beautiful they are. And then we'll call this one a wrap. 10 tests that succeeded. Now that's my digit recognition algorithm. So the next thing that we need to do is we need to make a class that will use this algorithm to construct entire numbers based on its digits. So if I give it a 4, 5, 6, I should be able to take each digit in turn and interpret the digit and then throw it together to create the number 456. That's the goal for next time. And then once we have that working, then we can use that to make a class that we can specify XY coordinates on a giant bitmap, like, oh, I don't know, an entire screenshot of the ending screen, and we can say, get me the number that exists at these coordinates, and the number exists at these coordinates, and these coordinates, and these coordinates. And then my plan from there is to feed different sized images, because everything is working off relative percentages of black pixels to non-black pixels. So theoretically, if we resized the image and just said, hey, this is your new width of your individual character boxes, and this is your new height, it should more or less still work. Although I think we're going to get problems between recognizing the 4 from the 3 because they're only 0.5% difference. And once you start resizing things, you might lose a bit. Well, you will lose a bit of quality. We might start getting different numbers though. Then we have to make our criteria for recognizing digits more fuzzy. But whatever the case, we have a good start here. Now I can just use in whatever program, whatever classes now, I have this iDigit reader, and I can just pull this in and get a digit from a bitmap. And if I need to change it later, I'll change it later. We could even make it selectable. Like I want to use the black pixel method versus I want to use some other random, weird, crazy algorithm we may end up inventing in the future. But all right, perfect. Thanks for joining me in this segment of creating a Tetris data extractor. We will see you next time.